Okay, good afternoon. It is day, I think 54. I might have done 64. Uh, um, so yesterday was a pretty shit video, in terms of length, I guess. In terms of quality, it was really good. That was a good leak code. But today I hope for a better video. I kind of just started. So I woke up today and got a coffee and just chilled a little bit, scrolled like Hacker News and watched some YouTube videos. And then I kind of just had like a day of cleaning. I cleaned the bathrooms, cleaned the living area, the kitchen, um, did all the dishes, doing laundry right now. So that took up a couple hours. I'm just doing that today. And I actually think I had a chance to go to the gym. So made I'd have to go right now, which I'm probably not gonna do. Um, Especially since I won't lie, I waited so long to do my laundry that I literally like this is the last like this isn't even a shirt. This is a just like a crew neck. I didn't have any t-shirts left. Um so actually if anything I'll go late tonight. But I say I'd go late tonight. But I actually have a career fair tomorrow. That's in Boston, and I am in Amherst. So if you know Massachusetts, that is a 2 hour drive to and then 2 hours back. So 4 hours round trip, which is not fun. It starts at 2 and it goes till I think 6. Um, I don't plan staying the whole time because it's a Boston company career fair. Um, Hosted by UMass Amherst has its main campus, which is like all majors, and then it has I'm pretty sure it's a business campus in Boston called Mount Ida. Um, and um, so that's who's putting it on is the one in Boston, that campus. So um, but my point is out of I think like 60 employers, I'm pretty sure only like 10 are looking to hire computer science internships. So hence I don't think I'll be there for 4 hours. Maybe I will be. I don't know how long the lines are and how busy that. I mean, the internships that happen at this main school, usually I can get through. I don't know. I remember when I waited for the Dell line, that took like 40, 50 minutes. But that's a pretty big company. And I don't think there's any big companies that are recruiting computer science for internships. Um, so, um, so I don't know. If I have to stay till 6, I'll stay till 6 to hit everything I want. The plan is though, um, is to research, and maybe we'll do this actually in the video. Research each company um, that is recruiting and look at their internship posting and just take away, what their vision is, their mission, what their company does, what technology they're using, what projects they've done, all that. And so I think my approach at the career fair is going to be usually it's weird. So the thing that I hate is usually it's like, oh, you'll go up and you'll be like, hey, hi, my name's Devin, and they'll be like, oh, I'm blah blah blah, um, and it'll usually lead into an elevator pitch, right? But the whole thing is sometimes I've done that, and then I'm like, I'll say I'm looking for an internship, and then they'll be like, oh, like we're not doing that. Even if they listed it on the website, they're like, no, we're not recruiting for an internship. But on the flip side of that, if I lead with, are you guys recruiting for an internship? They'll do a whole spiel. They'll just go into whatever they were usually have planned to talk about. So I'll be like, hi, my name's Devin. They'll be like, hi, I'm blah, blah, blah. And I'll be like, hey, I was looking for, an internship for the summer. Are you guys offering that? Is that like something um, something you're hiring for. And then they'd be like, yeah, we're hiring, blah, 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 blah. The internship program, blah, blah, and then they'll go into their thing. And I kind of hate that because then it's like, it's weird to follow that with, oh, cool. Well, I'm Devin. I blah, 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 blah. And just doing like a scripted, it's just like a script after a script. It feels not good. I like, I like to lead with, my elevator pitch is usually like, um, hi, my name's Devin. I'm a junior at UMass Amherst studying computer science. Um, and I've been a little I used to just list off at like pretty much resume list off of like um previously I've worked at the research lab at UMass Amherst doing novel view synthesis work. In the last summer, I did research at the University of Houston for vulnerability detection, and I've done projects in web development and blah 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 blah. I think what I want to do is when we look at these job postings and we look at the actual technology they're using in the projects, I'll do something along the lines of like, I'll still be like, introduce myself, say I'm a junior studying computer science looking for an internship, right? That's the first base. Then I'd say next, I talk about my previous experience. And then after I talk about that experience, because I'm only going to talk about that last internship experience, um, and then I'll do something like, before I list off projects, I'll like confirm with them. I'll be like, hey, so I looked at your job posting for the internship, and it looks like you guys work with, JavaScript and Python or something like that, and you've worked on projects like XYZ, right? And I'll get confirmation, oh, yeah, that's what we work with. And I'll be like, oh, great. I've done projects X, Y, and Z that work with these technologies, whatever. This is what those projects were, how I use these technologies. Um, and yeah, I guess the only thing is like the transition out of that is like, so I've now stated who I am and what I've done and how that relates to like what they're doing. And so I mean, ideally, if we break it down at the simplest level, they're there to find interns or full time, whatever, but focusing on internships, people who are skilled at the right year in college, um, and ideally have work in their tech stack, right? So if I list off, I'm a junior, I've worked, I have a previous internship experience, um, and I list off like the technologies and whatnot, um, to them about whatever relates to the job. I'd assume like what do you even follow that up with? I've pitched myself to you. I'd assume it's like, like where does that roll into? It's like I need something to play off of after that. It's like, um, yeah. So it's like I do that pitch and then I say, so I was wondering, I need a transition question like to prompt them into something that I want to hear, right? I need this to be um as in my control as possible. So, um, hmm, I guess like, so I'd probably end my thing with talking about the projects that relate to what they work in, right? I would probably maybe trying to think of like something like a leading question here. Um, mm, I mean, okay, where my mind's going is something down along the lines of like saying, see, I hate doing like everyone asks like, oh, given that, what kind of projects would I be working on there? That's not really where I want to lead that conversation. Like I want to almost funnel them into giving me, yeah, I don't know. I mean, in my head, the best thing is you get like a casual conversation going on. And it doesn't sound like I hate the interactions in previous career fairs where it's like just script after script after script, where I do my elevator pitch, they do their pitch, and then it's just done, right? It goes nowhere. Um, and that also it really does depend on the person, the recruiter as well, who's there. Like if it's an actual software engineer, usually I can usually the conversation will be a lot less scripted, and like usually there was for I just what comes to mind, I've had like conversations with defense contract companies with like engineers there, and like cybersecurity companies. I won't say the names, but like um and those were like the best conversations with the engineers there, because I could talk about in depth like the stuff that I've done and the technologies I've used, and they can like, kind of almost like a technical interview right there, and they can kind of gauge um where I am. I think a lot of my past failure is not looking up exactly what they do and being prepared to answer questions in that domain. Um, for instance, a cybersecurity company is obviously going to be operating in some degree on Linux based machines. Now, I've used Kali Linux, right? Um, to the extent of just like a daily driver, not to like use it for anything useful, just to like get a feel for how Linux operating system works a little bit. I've done like disk mounting and stuff like that with Linux with like a USB and whatnot. That's about it. And so I was talking to this guy, and he says, "I see you have Kali Linux listed." Um, and then he asked me like a particular question. To this day, I don't even know the answer to. Um, Mainly because I forgot it immediately what he asked, but it was something about like it was something specific to maybe even Kali, and he was like, "Oh, have you ever done this?" I'm like, "No." And he's like, "Oh, okay." And probably like right there in his mind, he just like wrote me off. But anyways, where am I going with this? I'm just going with I need to work on getting from my pitch to something, I guess. Something that isn't automatic out of them, scripted. Their spiel, make them think a little. Obviously, show them my interest. Make sure they understand that I put in time beforehand to research them and understand what I want to talk about. Just sell myself to them. And so at the end of the day, when they see my resume, it pops in their head, oh, that was, just a good impression, and, whatever. Also pushing for contact info to follow up. A lot of the times, um, like if they talk to 100 people, I'd assume probably like maybe 15 or 20 of them would ask for contact information. And so if out of those 15 and 20, maybe 10 of them actually do a good follow up and like say, "Hey, I love talking with you. Loved what I read and talked about with the company. I would love an interview for more time to talk about um, what I can bring to the team and learn more about this opportunity," or something like that. Um, and that, shows them you're probably above that 80% of the other people who didn't follow up. The only time that other 80 probably would get reached out to if they were just that good. And it's like, wow, this person's impressive. But I don't know. I've been rambling quite a bit here, but yeah. So that's at 2 p.m. tomorrow. So I'll probably be leaving here around noon. I woke up a little later today, so I'll pop 2 melatonins, and hopefully I can get a recording in before I go. If not, then it'll be a late one, probably a pretty shitty video. Um, but on the other hand, maybe I don't know. We'll see. Um, yeah. Um, I had no plan for this video, and so I think what I might do is actually go to the gym right now and then think about what I want to do. and maybe get some stuff ready, and then we'll do that. So, um, yeah, we'll probably do a LeetCode as always. Um, I forget if I'm done intervals or not. I'm not checking right now. We'll check later. So we'll do one LeetCode, maybe two if the first one's quick. And then I don't know, maybe read up on something like I said, like a transitional thing. And then maybe for the first time in a fucking 4 days, actually work on the project that I've been pushing off, and get some solid work done on that. So that's probably the plan. But I will be back in probably hour and a half to like probably no earlier than 4, unless for some reason I decide not to go. Um, but yeah, okay. I'll be back in 1 second, and we'll probably do a LeetCode. Ah, okay, I'm back. I went and picked up the book, uh, operating systems, 3D pieces. Um, this is quite the fucking read. It's like 700 pages. Quite a lot. I'll read the table of contents to you. Actually, I haven't even read the table of contents. I just heard it was a good book for. I wanted to learn more. I took so I took a how computers work class, and so that went into like we use like a gate software, whatever you want to call it. To design gates like simple logic gates. And then it moved into like learning about maybe like a LRU cache, or learning about registers, or learning about that stuff. And I'll be honest, it's still really abstract in my mind of how it all works together. So I wanted to get this book, and throughout the semester, just go through it, and hopefully, I mean, I say hopefully finish it, but that's quite the tall task. Um, Anyways, so we started out with an introduction to operating systems with virtualizing the CPU, virtualizing memory, concurrency, persistence, design goals, history, and a summary. And it gives me some homework to do. Fun. Um, so that's the first 20 pages. So it's just like going over some stuff. Then we go into. Wait, let me move my keyboard back. And then we go into uh, uh, um, virtualization. Yeah, we go into virtualization. Talk about a process API, process creation, process states, data structures, and a summary of that. Then we go into process API, the process API in detail, limited direct execution, then scheduling, which that section goes over scheduling metrics, first in, first out, shortest job finish, IO stuff, more scheduling for priority, scheduling proportional share, ticket mechanics, how to assign tickets, the Linux completely fair scheduler. Cool. Every single one of these has a homework, by the way. That's pretty cool. Multi-processor scheduling, synchronization, cache affinity, single queue scheduling, Linux multi-processor schedulers, and then we have a summary on virtualization. So that whole thing was virtualization. That's the first 150 pages of the book. And then we go to memory virtualization, address spaces. That's good. Memory API. Next page. Address translation. Segmentation. Free space management. That's another one we went over. Kind of was like how to Oh, we did this for Advent of Code as well. Of like you have like a list of like numbers that are in like an array and there's spaces everywhere. And it's like as you like take something out or remove something, like that's still open space, but like you it's like let's say you wanted to put in something that was like eight like let's say like a gigabyte of memory or something like that, right? But there's not enough space. But technically, there is if you compressed everything from everything you removed. Like there are some things that could fit into like if we reassigned the memory mapping to spaces before where it currently is and like free up the end, and it could give us a lot more space. I'm thinking that's what this section's on. Paging, paging's a big one. More paging. Beyond physical memory, swap space, bit stuff, page fault, policies, cache management, um, random, uh, LRU, um, complete virtual memory systems for looks like Linux. Uh, um, a summary, and then we go to concurrency. That's the second. Oh. So the first one's virtualization. This is the three easy steps. The first one's virtualization. Next one's concurrency. So concurrency. So that was the first 300 pages up until this next step. So concurrency. Um, what are threads? Thread creation, shared data, um, thread API, locks. The idea of locks, evaluating locks. I've never heard of locks before. um, Lock-based concurrent data structures, linked lists, queues, hash tables, um, condition variables, semaphores, common concurrency problems, what type of bugs exist, non-deadlock bugs, deadlock bugs, event-based concurrency, an event loop, API, asynchronous I/O. Um, And so that took 130 pages. And then the third easy step is persistence, I/O devices, hard disk drives, redundant arrays of inexpensive disks. Okay. Files and directories, file system implementation, locality, crash consistency, log structure, flash-based SSDs, data integrity, distributed systems, file network system, and that's it. That's it. So it looks like first part. Well, it doesn't look like first part's virtualization. Second part. See, the second part is something like a lot of the stuff in there. I'm pretty sure that was the part I hadn't heard a lot of. And then the last part seems more so high level stuff like file management stuff and whatnot, and SSDs, storage, data management, and then the low level or the virtualization looks like it covers. But yeah, this should be a good book, especially going into computer architecture. So I'll start reading this tonight and then try to get through. I mean, if this is what this is 700 pages, um, or is it 600? 600 or 700? I'll call it 700. 700. So let's just say I wanted to finish this by like the end of the semester, right? I would say, don't look at that. I was watching the podcast of Travis Kelsey, and I don't know if you watched the game, but I wanted to see what he was saying about all those flags, and he pled the fifth. So I was taking a screenshot of the caption. Okay, so I have until like I don't know, say like May I'm just like timing end of the semester. So it'd be like May 19th. So that's what? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 weeks. 16 weeks times 7, that's 70, like 102 days. Is that right? I think. So 102 days, if every single day I could just read 7 pages, 6, 7 pages every day, then end of semester will be done. So that's not bad on average, because every day I'm not gonna. There's definitely gonna be days that I don't read this. So on average, 6, 7 pages a day, not bad. Okay, anyways, that's enough of that. So I think I'm gonna do a LeetCode first, and then you can see I have pulled up here. Oh, let me. Bop bop. Ah, um. God damn. I Oh, fucking. Um. I pulled up here the career fair. Um, and so if we sort this by, let's just sort this by majors, view all, give me computer science. Anything else I should add here? I don't think so. Okay, so computer science. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 companies hiring for that. How many for internship? Internship, 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 internship. Oh, it looks like all of them. Okay. Okay, so apply I'll apply to all of we'll do the LeetCode, and then we will go through this list and we'll apply to whatever posting they have up. And on top of that, we will um start making a list I can print off of every single. I don't even have to print it off. I can just do it on my phone. But every single company, what their tech stack is, what their oh my god, what their like mission thing is, projects they work on, stuff like that. Um, yeah. Okay. Roadmap, backtracking. I hate combinations. Some N queens. Let's see how hard this is. Ooh, the N queens puzzle is the problem of placing N queens on a N by N chessboard so that no two queens can attack each other. A queen in a chessboard can attack horizontally, vertically, and diagonally. Yep. Given an integer n, return all distinct solutions to the n queens puzzle. Each solution contains a unique board layout where the queen pieces are placed Q in space. Wait, what? Oh, so if we're given 4, it's a 4 by 4. Huh? Then why is this only a 2 by 4? Oh, it's just doing line by line. Okay, I see. So each array represents an entire board. So if we have n by n, it's a 4 by 4. So we'll have one array of 4 elements. And we want to place as many queens as possible without them being able to capture each other and find how many. Well, so the good thing is that we know we need to place n amount on the board. So any solution that doesn't have a count of 4 queens. So again, this is backtracking, so we're gonna have a DFS. Um, can you see what I'm looking at? Yeah, you can see the board at least. If you couldn't see, it's that. So how do we want to approach this? So you'd probably want to loop through. It's probably going to be something where we want to, wow, that'd be a lot, right? If I started at like this square, right? And we went through and we said, okay, if we place one here, where can I place another one? Well, I can't place one here and I can't place one here and I can't place one here. So the first place I could place one would be right here, right? So I place that here. Now, can I place something here? No. 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 Can I place something here? Yes, I can. But then that's nothing. So that's I never hit the base case, right? So starting here would never result in 4. So then we go to the next one. Can we place one? We place one here, and then we go through, right? And we say, can we place one here? We go through and we're like, where would be the first place we could put one? It would be here, right? I'm just trying to think if there's like, um, then we place one here, and then we go here. Can we place one here? But still, we'd have to. Wow. See, this is interesting because it's going to be like we know obviously it can't be on the same coordinate row or column, right? But how do we get diagonal? That's the hard part here. Like if these are rooks, that'd be a lot easier. But it's not rooks, so they can go diagonally. Something you could do is when you place a queen, you then fill its row, column, and diagonals with a different character, right? And so that way, when you loop through and you're trying to find where you can place, right? The first instance of where you can place something, you'll place it. I'm just trying to think in the scenario where you, like so I place this one. Well, I guess place this one. Or no, I guess that's no. I think if we loop through and we make sure that we test every single square with a starting piece, it should give us a result. But the hard part here is actually tracking if it's valid placement with the horizontal, right? I do think maybe doing something like making a helper function that you call to, that if at any point you can, like when you first place a queen on the board on each iteration, it calls a helper function and it fills out this array of strings, right? With the proper strings of like, and then at the end we can convert anything that isn't a queue to a period and then return that, every single variation of that. There's one thing I'm going to do. I'm going to peek at the solution and see if it is like a lot of code. I just want to make sure that I'm not like overthinking this. Okay, yeah. It's a decent amount. It's like 50 lines. Okay. That's all I wanted. Okay. I think I just want to think, is there any different way I want to do this? Because the whole idea, again, I'll go over it, is we do DFS where we check this one first and it'll go down a recursive loop where when it does this, it calls the helper function and it will make all four of these strings, or five or six or whatever, how many n times n is. And it'll loop through and it'll make every single one of these strings. And every string at index of whatever, right, that isn't a queue. So we'll first initialize all the strings and all the, not all the arrays. Anyways, we'll first initialize um like placing a queen here, and then we'll set like this, and this to like T, let's say, and this diagonal, right? So this whole row, and this whole diagonal will have T's. And then we go through, we do another loop with this new updated board, and we say, okay, if the current coordinate is not a T or a Q, place a queen there. Call to the function that now fills out and writes any T's, even if there's a T there, right? And then go through again. And if we ever hit the base case of, and then we'll have a count. And if we place 4 Qs, right, then we return, or we append that to the result. So we know that we're going to have this, right? And we're going to append an array to this of that state, that board state, as a valid board state of n queens. If it doesn't reach that, right, then it doesn't matter, right? It just means, well, actually, if there's never a return on any of those, it would just mean that there's no possible solution. Now, in this scenario where n equals 1, right, we know it's going to be a 1. We'll just go through when we do that. Okay. So that's my approach. I'm going to be right back. I'm going to get a drink and use the bathroom, and then we'll start this. I'm back. Sorry about that. Where were we? Okay. Well, I know I can just say this. What did I say? We wanted to do like an index. No, we wanted coordinates. We wanted an X and a Y. It's going to be so much better to treat this as a fucking... Actually, no, I can do... No, X and Y is fine. We're looking at X, Y in like the current board, right? So we know the board is going to be equal to n times n. Okay. So board is equal to an array of this times n for that in range. So for right now, we'll just print board and we'll pass through DFS board 0, 0, and we're gonna return res. Ah, nice. So that's 4x4 with that. Cool, cool. Okay. So the actual logic of this though. Obviously we also want the function of place queen. So obviously again, we're going to want. Now, I don't need to place the board in here though, right? No, no, I guess I do because I'm going to be making a copy and sending that through since it's whatever. So for place queen, obviously we want the board XY, right? It's the same thing. Um, so on this depth first search, our base case is going to be numq equals 0. And we want to say if numq is equal to n, then res.append board.copy, and then just return. Right? If it doesn't equal that, then what we want to do is we want to say, okay, given the current board, can we place, so if board uh, at xy, or isn't it yx, yx? If board at yx is equal to a period, right? Then we want to call place queen with the current board in the current x and y. After we do that, that's going to take our current board that we passed through. Well, it's going to what? Return whatever the board edits are. And then we're going to take that board and we're going to say so like I want to do that. But we also want to increase the y at some point, right? So how would we do that? It would be like I mean, we want a for loop for index in range of just n. Or I guess it would be what? Row and column. Right? I don't know if that's what I'm trying to do. So it'd be on first iteration, right? We'd end up placing this, and so we'd have a queue with all these like T's or whatever. And we say, okay, for each row and for each column. So at 0, 0, right, where we currently are. We'd want to go from but you see, that's the thing, is that we're doing this whole loop over. This is just gonna have a it's gonna be infinite, is it not? Like first time I call it, we're gonna be looking at 0, 0 and call it on 0, 0. And then nothing changes, and then we call it on 0, 0. And it's just this infinite loop, right? The row and column never changes. Oh, you know what I could do? I could do something that is like if if x is equal to n minus 1, right? Meaning we're at the end. No, I guess it's if x is equal to n. If x is equal to n, right? Meaning that we're out of bounds, then we want to call this on 0 and y plus 1. Else, we want to call it on board at x plus 1 y, right? Let me check that DM real quick. Sorry about that. We are back. So the whole idea here is that we pass through, right? So on like first iteration, it's like, is x equal to n? Nope. So we're just going to keep going down. If at any point it equals n, right? Meaning it would be passed here. Now the only thing is we're going to have an index, a bounds error here, because we're checking if at yx is equal to this. But if x equals n, this, right? So actually kind of what we want to do is put this here, right? I'd assume is we just kind of want to say and I guess we'd also we'd want to do it on both, right? I think that looks good, right? Let's put a space there. So we still need to do this place queen. So the place queen is going to be, but let's not look at place queen right now. Let's just say, okay, def DFS. If num q equals n. Oh, we have to increase number of queens. So like if we get to here, we want to say num q plus equals 1, right? Right. So if at any point num q is equal to n, meaning we found enough, then we're going to just append whatever the board state is currently at to res. Right. Now we're going to check, okay, if x is equal to n, meaning that we have gotten to the off the edge of the board. So like, imagine there's something here. This would be now x is out of bounds. So we're going to say, okay, if x is equal to n, it means we've gone through the whole row. And so we're going to call DFS. Actually, if x equals n, right? We might not need this actually. Because if you think about it, what's going to happen here is y is going to go to 1 and we're going to be at 0 and we're going to go through here and then we're going to check at, okay, yeah, we don't need this because we're just incrementing the y and then going. So it'd be at that first square and we'll be checking that first square. So if x equals n, it means we're out of bounds. So we're going to call and move to the next whatever. Now also, if at any point, if I guess kind of what we also want to do is if y is also equal to n. N minus 1. Right? I think so. That would mean we're out of bounds, so just return. So now we need this place queen thing, right? And so a little hack I could actually do is I could replace this with like I could replace this with what? Let's say an O. Okay. And so what I can do is I can say, okay, board at y at x is going to equal q. And now we need to loop through until out of bounds the diagonal, the horizontal, and the vertical, assigning it all to periods. Right? Actually, what we have to do is right here we say if board equals this, then we call to place queen. I don't want to increment this here. I want to increment this here if it's successful. Right? Because we're going to have to check here if it's valid, if the place queen is valid. The only thing, I think like my logic here is fine. The only thing is I don't know if how I'm passing board around is correct. I might have to be doing more copies than I am now. You know? Um, let's say this is board org. Let's just do that. Make sure that's fine. Um, ba, 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 ba. Yeah, okay. So this is gonna be the meat and potatoes. Um, so here, one second. I'm gonna use the bathroom, then we'll do this. I'm back. Sorry about that again. Um, 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 um. Okay. Yeah, but it's gonna be a lot. It's gonna be so much. If I run this right now, what happens? I knew this shit was gonna be a problem. I can't do this as just strings. You know what I'm gonna do because I want to move on to something else. Let me cook up a little chat GPT real quick, and then I'll be right back. And we're just gonna look and see if the solution is close. So before we, I'll just like the whole point of these is for my approach. I'm trying to get better at my approach. Like I know all the syntax to get this done. It's just whatever. So I would say I'm gonna end up having to change this to a, you know, to an array. And then what will probably happen is when we append, we'll have to reformat. This whole checking out of bounds thing, I think, is good. And the place queen, once I implement all of that, like checking, um, if it's valid, I think that's like good. Is there any flaws here? So we're looking, so if this successfully goes through, right? And we place the queen. All right, so we place the queen and it fills that row, diagonals in the column. And then we move to the next spot, right? Oh, you know what? I assume anytime we place a queen, we can just move to the next row because that whole row is going to be off. That's actually a pretty good optimization, right? Yeah. If we place a queen on any row, we can no longer place anything on that row. So why would I be checking that row? Yeah. Well, I assume we'll do something like that, and then yeah. So let me try GPT. Right back. I'm back. So I'm cut off, but um, it was pretty much what I said, except so it is making a list of lists, and then it changed this to an is safe function. It's fine. Checking vertically, diagonally, horizontally, whatever. If so, it returns true. And so if it returns true, then we place the queue and we call DFS on row plus one, right? Because like I said, we start at a certain row, and then if we ever place something, we can just go to the next row, and then this whole thing is in a loop. Like that's so smart. This whole thing's just in a loop, so it's gonna do each column, and if at any point we like find somewhere we can place a queen, it's just gonna skip to that row, and we're gonna reset. Right? It's just gonna call DFS, so the columns back to zero. Um, and then after it calls that, it backtracks by removing the queen, and then it makes sure it continues the entire row, right? So smart, so smart. Yeah. So I'm just gonna copy this over, um, because so I mean if we look at all the differences here, right? Its res is the same. The board is the same except for making a list of lists. And then there's no numQ, right? Um, because we don't need it. It's just going to return every single, you know, possible solution, which actually maybe is a fault here. Let's actually see. Maybe this does fail. There's a chance it does, at least. Aha. Oh. Um, change that back to that. Change that back to that. Should just be that, right? That should fix it. Yeah. Oh yeah, never mind. Beautiful. Beautiful. Okay. So where did I go wrong in this? I should have just done this list of lists thing. I thought you could index through a string. I think you can, but doing like a 2D array is just so weird. Like I think the problem is doing the y coordinate. It just doesn't work. You're in an array, you can't do a 2D array of strings. Um if it was one string, I could like index through it, but anyways, is safe. This is I just didn't want to flesh this out, right? Um I want to see these solutions. Like what did they do to get around that? Oh my God, it just ripped this. It literally, ChatGPT just ripped whatever this was. Cool. Yeah, no, cool. Wow. Yeah, it's literally just what. Okay. That's actually pretty good on my part, though. Like, we did this correctly. The only thing was a lot of optimization stuff I left out. And this would have messed up. I would have found the error eventually, but what I know is wasn't doing this like, you know how it assigns Q and then it does a DFS, right? And that's what we were doing. We were if it was correct, we'd place the Q and then we did a DFS. But then we weren't checking the rest of this. Actually, no, we were, I think. Maybe. Because we were missing out on the whole like if we're placing a queen, we don't have to check the rest of the row for that solution. Whatever that solution is going to be. If it's a solution, right? And we place the queen there, then we can go to the new row. Otherwise, we're resetting that back to a period and just going to the next one, placing a queen if it can be placed, and so on and so forth. And that way we can find every single solution. I want to see, there has to be, okay, so column, post diagonal, negative diagonal, same thing. Copy equals this, append copy. For C, for column, if the column is in column, or if R plus C is in the post, continue. Otherwise, okay, I don't like that. Okay, bit mask. Ew, bit operations. Bit operations are so cool though. Like, could you imagine getting asked? Like, I'm guessing the video has like a yeah Facebook. Can you imagine being in a Facebook interview and someone hits you with the fucking bitmask solution? I'd hire them on the spot. There's no way. I wonder how many people have ever like done this solution in like a interview with this question. It'd be crazy. Okay, so what did we learn from this? Just convert the shit to an array, right? If we're doing any type of traversal, we want an array. An array is just the easiest thing to index through. Um, I'd say also, what else did we learn here? Mm-mm-mm-mm. Just think about optimizations, I guess. See, the weird thing is because this is a hard. you know, this takes a while to do, at least for me. So if I was asked for it in an interview, I don't care that much about the optimizations until they ask about optimizations, right? I mean, like I caught that whole like row thing of like you can just go to the next row, which is an optimization. Um, but yeah. So okay, I'm pretty happy with that. I mean, my approach was overall pretty nice. I just didn't want to flesh out this whole is safe function. We were gonna find the answer going down the path that we were going. It just would have taken another half an hour, which wouldn't have taught me anything. Because advent of code was literally this all the time. It was just indexing one x back, one y back, or one x forward, one y forward for diagonals, or indexing one y back, not moving the x, or one y down, not moving the x, or one x forward, not moving the y, right? You have to just check all of that. Because, I mean, there's the whole for dx, dy, um, hx. I forget what, there's something that we were doing in the advent of code that I guess we can go look for it. Um, um, advent of code. Hopefully one of these has day 7 maybe. No, day 10. Yeah, oh, yeah. For dx dy, so that's for horizontal and vertical, and nx and y is, oh, that's new x new y actually. So this is for, well, actually directions is 0 1, meaning we'd be moving technically down, up 1 0. So this is non-diagonals, right? So we're just checking non-diagonals. There's one where we're checking diagonals. I remember. I remember it well. Um, Definitely not day 2. Day 6 sounds about right. Oh my God, it actually was day 6. Walk north, right? Oh wait, walk south, walk east, walk west. Okay, not that, not that. Day 4. Yeah, yeah. This is the one. This is the one. So this was trying to find like an MA. This is a word search basically. Check horizontal, check back horizontal, check vertical, check back vertical, check diagonal to the left, right, left down, right down. I had to check and then run all checks, right? These are all my check functions, and we just ran it through. Oh my God. Anyways, this is just me showing I've done that a lot, right? So, but that's the thing in like an interview, like so here we ended up doing check vertically, check diagonally, up left, up right. Up left, up right. Why are we only doing, so why do we not, I know again, we don't have to check horizontal, right? Because if we're placing it here, it means that it's fine horizontally if nothing is running through it vertically at where we're at. Um, oh, you know what? It's because if we're trying to place a queen, like say here, and we check like up here or here, right? There's nothing, whatever. We check up here or here. We check up here or here. So now when would this be a problem? Is if we were like placing it here, right? Check here. Oh, nothing. There'd be never a situation, I think, where because we're always going to be placing on this top row first, right? So we're always kind of looking up, right? Because we're never just going to place something down here and then go up here and place it. Yeah, okay. Then you just loop through, check if it's a queue. If not, return false, go through this. If at any point it equals queue, return false. Otherwise, just return true that it's safe. Yeah. Okay. So there's two. I'll be honest, we're not getting to code visualizer today. Sorry. I know. I'm horrible. Two things I wanted to do. One was check out if we're gonna be leaving my beloved Arc because it seems like they have given up on this browser. Every time I go and look at the Reddit, people are kind of just enraged at the team and how they're not doing as many updates. It seems like their vision is kind of not with this browser anymore, and it's just gonna go downhill from here. I've liked Arc, but if I can jump ship to a better mission, a better vision, I wouldn't mind. And so I heard some good things about this browser. What was it called? Zen. Was it the Zen browser? Yeah. I've already looked just like at here, but look at how nice. So it looks like the Arc version for Mac OS. So the Arc version of Mac OS has these tabs and has everything here, and so there's no top bar, which is beautiful. Now, maybe it's showing the Mac version of it, right? This does look Mac-ish. But this looks exactly like Arc, but I've heard number one, it's open sourced. And number two, um, okay, no, never mind. On Windows, this is literally the same thing as Arc. But I've heard good things. So we'll just try it. If I like Arc better, we'll go back. But I want to try this out. x84, download the installer. Fuck them regrets. I don't know, BBS, I like A cups. And yeah. Anyways, and then I also want to work on transferring, or no, getting prepared for the career fair tomorrow. So, but them regrets. Firefox. Ahena. Do a standard setup. But regrets. Welcome to the comment. This is exactly what Arc fucking did. My color preference. I don't fucking know. Collapse toolbar. Multiple toolbars. Single toolbar. Person one. Is that me? Oh, DuckDuckGo, Google. I do like Google. Won't lie. Oh, I like. Oh, I did see. Interesting. So these are all bookmarks up here. All right, this is just gonna open a lot of. Oh, oh wait, no, it's this. Yeah, yeah, yeah. I'm opening it up. Sure, save it. Beautiful. Capital One. Turn you to this way. Privacy. Bam. Oh, I like. Oh, I like that animation. It's pretty smooth. You block origin. Nice. Not bad. What's down here? Oh, can I? Pin. Ah, okay, so those are downloads. Okay, so I can hold that to. How do I? Oh, there we go. Okay, let's add some workspace here. This is home. Um. Uh. Do I say? I don't know. Software, and then I like scoop. Sorry, school book. Hey, look at the little icons down there. Um. What was this? What the hell? Why are you like that? Give me. Was this software? Beautiful. I only really need that for now. Oh, and it like highlights it. Cool. And so this has so these are all I'm pretty sure do I just drag it? Oh, are there no folders? Whoa. What is this flexible space? Whoa. The fuck am I looking at? Email link? Whoa, 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 don't want you looking at those. Okay, this is sick. Nah, this is sick. Ah, no, no, I like my mountains. This is sick. Don't look at the legal streaming site. Don't look, guys. Um, what do we want on here? ChatGPT. Okay, I hate dismiss, but yeah. Cheers. YouTube, ChatGPT, Reddit, Twitch. What is that logo? The fuck? Anything else? Not really. Okay, I like this a lot. Like the just the look of this, right? I like how it like if we go to Arc, right? I hate the static top bar, I won't lie. That's what I hated about Google. Um, Also, this whole like this side just looks cleaner than this. Oh, and it does. I didn't even realize. Yeah, it does have the link up here. And it has the quick link, right? Verified. Anyways. Ah, that's sick. And I mean, it has a perfect. This is so cool. I really want to um this is sick. Developer, new window, open file, find sidebars, password sync tabs. I'll mess around with this later, but I mean, and then yeah, it's cool that there's all my bookmarks from uh whatever the fuck. Sick. All right. All right. Honestly, I think I'm going to call it here and do that company research on my own. Because I also want to apply to internships while I'm doing that. And that involves me entering my address and whatnot. And I don't want to do that on video because even though I don't think anyone would do with that information, you never know, and I don't want anyone sending something to my house. So yeah, I'll end it there. I'm gonna play around with this new browser and update you on what I found tomorrow. But yeah, so um, not a horrible video. The leak code went okay, and I'm excited about this browser. Um, I just need to start earlier in the morning. I've been doing just other stuff in the morning, so but it's better when I record these in the morning. It always has been. So yeah. Anything else? I think I'm gonna like do like a little book review every day, like what I read the day prior, or before I started recording the video, and just spark note what I read about in the operating systems book. And then yeah, yeah, not much else to say. Keep up with the LeetCode or two a day at bare minimum. Try to work on my projects outside of that. But yeah, I will see you tomorrow for nothing promised other than at least one LeetCode. So, so yeah. Don't know if I'll see you before or after the career fair. Um, Still not looking forward to driving 4 hours tomorrow for that career fair, but I'm taking any shot I can get at an internship. So, gotta go. Anyways, yeah, I'll see you tomorrow. Take care. Bye.